Hello everyone, welcome back to the channel. In this video, we're going to talk about continuously compounded interest. So how is this formula different than just the compound interest formula? Well, at the top we see, and we've done a previous video on compound interest, and I'll link that in the cards right now, but we see the balance of an account earning compound interest would use this formula. A is equal to P times 1 plus R over N raised to the NT power. So we said A is our account balance, P would be our principal or the starting amount, and then 1 plus, and then R is our rate, our interest rate expressed as a decimal. N is the number of times we're compounding it annually, and then T would be, after how many years we want to figure out this balance. So for today in this video, as the frequency N of compounding approaches positive infinity, the compound interest formula approximates this equation here. A is equal to P times E raised to the RT power. So you can remember it as A equals PERT, okay? All right, so let's take a look at an example here where we can use this continuously compounded equation. So we're going to be comparing, we have our bank account, we have our cousin's bank account. Ours is represented by the equation, A equals 3,900 times E to the 0.05 T. And our cousin's account is represented by this graph that we see at the right. So number one says, which account has a greater principal? So principal, remember, is just our starting amount. So if we see in our account, so I'll use ours, right? We see this number right here. This would be $3,900. Okay, so for our cousin, that's going to be essentially when X is equal to 0, right? That's year 0. So if I plug in 0 for T, that's going to become E to the 0. Anything to the 0 power is 1. And then 1 we would multiply, and that's how we get 3,900 for our account. So basically what we see right here for our cousin is our principal would be our y-intercept, or the initial value that we are starting with in our account. So which one has the greater principal? Our cousin is going to win that battle. They have $100 more than we do at the beginning. Now, number two says, which account has a greater balance after 14 years? So for our account, ours, we can say our account balance is equal to our principal, 3,900, times E. Our interest rate is 0.05, and now we're going to figure out in 14 years how much we would have. So in our calculator, we can do 3,900, and we can do times E to the 0.05, and then in parentheses next to 0.05, still in the exponent, I'm going to put 14 in parentheses. So I hit enter on that, and let's approximate this to the nearest dollar. So we have $7,853.64. So we'll just say $7,854, okay? Now for my cousin, let's approximate on our graph here. So if we look at our graph, let's go year 14 would be right here, okay? And so now we can put a little point right here where we have that intersection. So we know this would be 9K, right? 9,000. So it's a little bit more than 9,000, which is already more than our 7,854. So we know we're good for our cousin. So let's just say that our cousin has a balance of, let's say the amount would be $9,250, right? Just approximating that there. But we do know that it is higher than 9,000, which tells us, once again, our cousin will have the greater balance, okay? And so that's how we can use the continuously compounded interest equation of A equals P times E to the RT.